Hello everyone, welcome to EECS 216 Labs. I'm Andy, and this will be a crash course on using your AD2 and specifically the Waveforms software. Now the purpose of this lab will be to get you up and running for Lab 0 and help you gain some familiarity with the AD2 and the software in general. Now how I have the AD2 configured is by connecting the scope channel 1 positive jumper to the waveform generator and the scope channel 1 negative terminal to the AD2 ground. Now I've connected those through the jumper cables provided in the hardware kit, and I've connected the AD2 to my computer via USB. So if we go back to the Waveform software, I've already confirmed I'd like to connect to my device, and I'm ready to start using it. So far and away, the most common feature you will use on your AD2 is the oscilloscope, which you can open by just pressing scope. And the second most common feature you'll use is the waveform generator. And the software is nice in the sense that it will tile both features on the same page, so they're readily available. Now to show you how the scope works, I'll begin by outputting a simple 1 kHz sine wave from the waveform generator. This is just the default wave that they have configured. Alright, so I press run on that, and if I press run on my scope, you can see a 1 kHz sine wave. Now it seems to be undulating a little bit, so I'm going to check my cables, and I see that I didn't plug one in all the way. So I guess that's lesson number 1, always make sure you have tight connections. Alright, so I'm not using channel 2, so if I go over to the right pane on the oscilloscope menu, I will uncheck that. Now, the most important feature on this right-hand pane is most likely the time basis, because if we up the frequency of the wave we're examining, let's choose something like 50 kilohertz, we lose the fidelity of the signal we're trying to analyze. So the time basis allows us to zoom in into the signal so we can observe it in more detail. Now this indirectly changes the sampling rate, so the smaller the time basis, the faster the oscilloscope will sample. Alright, so we're examining the wave that we're outputting, and that's probably the most basic functionality. Now, some common things you might want to do are take measurements, which, as you might imagine, are accessible through the Measurements tab. Press Add. In almost all cases, we'll use a predefined measurement. And then you have the choice between vertical or horizontal measurements. Let's say I wanted to measure the peak-to-peak voltage of our sine wave. We can do that. We can also add a horizontal measurement. Let's do the frequency and see if it matches 50 kilohertz. And if we look, it's measuring 2 volts peak to peak, which makes sense as our amplitude set to 1 volt, and the frequency is at 50 kilohertz, which is the same as what we have it set. Alright, so another feature you might want to use, I'm going to get rid of measurements just so it's out of the way, are cursors. Cursors can be used to identify interesting behavior. You'll see the uses as the labs go on. So let's press X cursors, add a normal one, drag it to the position of interest, and then one cursor isn't all that helpful, so we can add another one, drag it to where we want the second cursor, and down in the cursors menu we can set the reference of cursor 2 to cursor 1. So that will give us a delta between the two cursors. And if we look, we see that the delta is 20 microseconds, which is consistent with the period of 20 microseconds as we have the cursors set one period apart. All right, so that's the basic cursor functionality. Something else you might want to use throughout the labs is the triggering menu. So I'm going to stop the output from the waveform generator, and I'm going to configure a single pulse. I'm going to make this symmetry 1% and change the phase going the wrong direction, so it's in the center of the diagram, and I'll make the amplitude 5 volts. That's actually the maximum the 82 can output. And this is an extremely short pulse, so if I were to run it, now you can see it because it's repeating. So one way to change the frequency of repetition is to change the symmetry way down. All right, so I don't see anything now. Maybe we went below the limit. All right, so we see a peak every once in a while. Now, we're not zoomed in anywhere close enough to see any detail of the peak. So let's zoom in. And herein lies the problem, in the sense that we can't even identify the peaks. Or you can, but it's extremely jumbled. So this is an example of where we might want to set a trigger. So I'm going to stop the output. I'm going to choose normal on channel 1, rising, and since the output's set to 5 volts, we'll choose some intermediary value, 2 volts. So when the oscilloscope senses a 2 volt rising spike, it'll auto trigger. And the way we start is with single as opposed to run. So you'll then see an armed message in the oscilloscope, and then if we press run, it should, in theory, capture it. So maybe it didn't capture it in this instance because our level was set too low and we weren't zoomed in enough. So let's try this again. Let's press single and let's press run. Oh, and look, we've captured the waveform in the center of our scope so we can further identify it. And if we look closely, it doesn't really look like a pulse. And the reason that might be is it's such a high frequency pulse at such a high amplitude that it's beyond the capabilities of the 82. So that might be an example of a post-lab question that you'd have to examine something, and the trigger menu would come in helpful. Now, the last function you'll use when dealing with active components is a voltage supply. And this is very self-explanatory. You set the level of the positive supply and negative supply and simply press master enable on or off. Another thing that might be helpful to note is when you're not interested in using a cursor, you're just interested in viewing the waveform as it progresses, you can amplitude's way too high, so we might want to change it in the channel 1 menu to 2 volts. And look, we're observing the 5 volt 50 kilohertz sine wave. Alright, so that's all I can think of you'll need for lab 0 and in general the labs going forward. There's nothing too difficult. The hardest functionality probably is getting your cursors working and the trigger working, but other than that, the designers of the software did a pretty good job making it self-explanatory. Alright, so if you have any more questions, please feel free to reach out to course staff or an IA during office hours, and we'll be glad to help.